And as you can tell by my two computers, this is going to be some good stuff. So if you're ready, let's begin. The first question is, how do I return the response from an asynchronous call? This is a common question that is asked on Stack Overflow. Let's start by analyzing the common mistakes that beginners make when handling asynchronous results. In the demo code, we have a function called getAsyncData that makes a network request to get some data asynchronously. The result of the network request is handled by a success callback function. A common mistake is trying to store the results of the asynchronous response in a variable that is declared outside of the callback function. Beginners will try to return this variable, expecting the function to return the result of the asynchronous network request. However, the function will end up returning an undefined value, even though we can verify that the asynchronous response has a result which we can log to the console. So why does this happen, and how are we supposed to get the asynchronous result? The problem occurs because the asynchronous result was handled in a synchronous manner when it should have been handled in an asynchronous manner. Synchronous code is executed in the order in which it occurs in the program, but asynchronous code happens in an unpredictable order. Furthermore, asynchronous requests can only be handled after all of the synchronous code has finished running. This is true even if the asynchronous request is completed instantly. With this information, let's analyze the code to see what is actually going on. So first, a variable named result is declared, and it is initially undefined. Next, an asynchronous request is made. Since the request is asynchronous, it is processed on a separate thread and is not handled immediately. Next, the function returns. And since the result variable is still undefined, it returns an undefined value. Lastly, now that all of the synchronous code has finished, the asynchronous result is now handled by the success callback function, and the result is stored in the result variable. However, this does not change the value of the return statement. OK, so how are we supposed to handle the asynchronous result? The asynchronous result must be handled in the callback function. You should not try to extract the result and handle it outside of the callback. So for example, if you want to take the result and modify a DOM element with it, it must be done in the callback function. One approach to make this easier is to make the function accept a callback function as a parameter, so it is easier to modify the success callback. Let me demonstrate this. So here I'm going to add another parameter. Let's call it callback. And then I'm going to replace the success callback with the parameter. And now I can pass in the handle result callback into the function. And as a result, we can see that the callback handler will now output the results to the console. The next question is, what are JavaScript closures? A JavaScript closure is an inner function that is created inside of another function. The closure automatically has access to its parent's variables and parameters. Now here is the interesting thing about JavaScript closures. If you make the parent function return a reference to the closure, the closure will still have access to its parent function's variables and parameters even after the parent function finishes running. This is interesting because usually when a function finishes executing, its local variables are no longer accessible. Let me demonstrate this. As you can see in the code, I have an inner function defined inside of a parent function. I have a local variable called count that is declared, and the inner function will increment count and log it to the screen. Now at the end of the function, I am returning a reference to the inner function. Now I run the outer function, and I store the reference to the inner function into this variable called closure. And then I add this closure variable that references the inner function as the event handler to a click event. So what happens when I click? Oh, stuff is happening. And as we can see, we are still able to access the parameters and local variables of the outer function that has already finished running. Now, why is this important? Imagine trying to do the same thing without using a closure. A common way is to use a global count variable and have a function increment the global variable. This method works, but it exposes the global variable to be modified by other methods in the program. Also, if you do this too many times, you may end up with a lot of global variables floating around in your code. Now with closures, an outer function can have private variables that can only be accessed through this closure. This method keeps your code from ending up with a lot of extra global variables. The next question is, why is it bad to use the for-in statement to iterate through an array? Various internet sources will say not to use it, but why is it bad? Let's first start by explaining what the for-in statement is supposed to do. The for-in statement is used to loop through the properties of an object. In the code, I have an object with a few properties. And the for-in statement allows me to loop through the object's properties. But as you can see in the console log, the property order is not guaranteed. This becomes a problem when you are using it to iterate through an array where the index order is important. You can think of an array as an object with a list of integers as properties. And if the property order is not guaranteed, the array index order will also not be guaranteed. So is it OK to use the for-in statement to loop through an array when the order does not matter? Not always. So let me demonstrate the similarities and differences between a traditional for loop and the for-in statement. In this first example, I have over here, I have declared an array, and I will be iterating through it using a traditional for loop as well as a for-in statement. And as you can see in the console, the output is the same because it was a very simple case. But now let's look at a different situation. Over here in this example, I'm going to declare an empty array, and then I'm going to populate the 5th index. Now in a traditional for loop, I'm going to get undefined, 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 undefined for all the previous indexes, and then I'm going to get the number 5 for the last one. But in the for-in statement, it skips all of the undefined ones and only logs the 5th index. That's a major difference. And let's look at another example. In this third example, I'm going to add an extra property to the array prototype. This might happen if you use some external third-party JavaScript library. And the end result, if I use a traditional for loop, it just logs all of the indexes. But if I use the for-in statement, the extra property shows up in the console log, and it is iterated through. These differences do not necessarily make the for-in statement bad. There are just some things to consider when deciding between using a traditional for loop and a for-in statement. If you want to guarantee traditional behavior, though, you should definitely use a traditional for loop or use the for each method. The next question is, what is the difference between the doubles equal sign and the triple equal sign? The double equal sign comparison compares two values and checks for equality after doing any necessary type conversions. This means that the number 1 will be equal to the string 1 and will also be equal to the Boolean true. The triple equal sign comparison compares two values as well, but it does not do any type conversions. It does a strict comparison, meaning that the number 1 will not be equal to the string 1. The doubles equal sign comparison will not always work the way you expect it to. Let me show you some examples. So at the top of the code, we can see that 0 is equal to the empty string, and 0 is equal to the 0 string, but the empty string is not equal to the 0 string. And later, we can see that false is not equal to the false string, but false is equal to the 0 string. And furthermore, we can see that null is equal to undefined, but neither null or undefined is equal to false. And lastly, we can see that the string ABC is equal to a string object constructed with ABC using the double equal sign, but it is not true when you use the triple equal sign. So unless you want to memorize all the special cases of the double equal sign, it is safer to do a strict comparison using the triple equal sign. Do you ever struggle to get dates as a software engineer? Well, luckily, I'm going to show you how. To set up a date, you must first use the date constructor. The date constructor takes in arguments that can be used to specify the year, month, date, hour, and other aspects of the date. If the constructor is left empty, a date object will be created for the current date. Let's set up a date for February 14, 2017 by providing the right arguments to the date constructor. So let's do that here. And now how do we verify that our data is set up correctly? Well, there are several methods that can be used to access the properties of the date object. Let me demonstrate this. For example, if you want to get the year, you use the getFullYear method. And if you want the month, you use the getMonth method. And if you want the date, you can use getDate. So if I log this to the console, we can see that February 14th, 2017 has been logged to the console. But what if we want to modify our date? How do we do that? Well, there is also several methods that can be used to modify the properties of the date object. So if I want to, let's say we want to postpone the date for a month, we can use the setMonth method and pass in the new month. So let's do March. And as we can see in the console, now our date has been set to March 14th, 2017. Now that you know this, you'll be able to get any date you want. The next question is, how do I check if JavaScript objects are equal? I am going to answer this question for objects that have only primitive values as attributes. In this first example, I'm going to use a neat trick that uses the JSON.stringify method. I'm going to compare objects A and objects B by applying the stringify method to each of them. If I compare the JSON strings and the values are the same, it means the objects are equal. Let's test this out. If I log stringify AB, it shows that it's true, which means that objects A and B are equal. And if I log stringify CD, it shows that they are false. The next example is more programmatical. In the code, I have created a function called compare. It first checks if the objects have the same number of attributes. If they don't, it returns false. Next, it loops through all of the attributes and checks if they are the same. If any of them are not the same, it returns false. If it manages to make it through all of the attributes, it returns true. Let's test this out. If I log compare AB, you can see that A and B are still the same. And if I log compare CD, you can see that C and D are still not the same. The next question is, how do I sort an array? All arrays have a sort method that can be used to sort the array. The sort method takes in a comparison function that specifies how the array will be sorted. The comparison function has two objects as parameters and is used to determine which object is greater. We define the function in the following way. If the first object is the greater object, a positive number is returned. If the first object is the lesser object, a negative number is returned. And if the objects are equal, 0 is returned. The sort method applies the rules defined in the comparison function to sort the entire array. If the comparison function is omitted, the array will be sorted by the Unicode value of the stringified version of the object. Let's look at some examples. In the code, I have defined a couple of objects. They have ID, name, and price attributes of various values. And I'm going to add them to an array. So let's first log that array to the console. And we can see that the array is ordered in the way I put the objects in the array. Next, I have defined a couple of comparison functions that will sort the array in various ways. Let's start by sorting it using the byIdUp comparison function. So to do that, we do array.sort byIdUp. And as you can see, the IDs now go in ascending order. I accomplished this by subtracting the second value from the first value. It will return, if the first value is greater, it will return a positive number. And if the first value is lesser, it will return a negative number. It's a quick way to sort numbers. Next, let's test another comparison function. Let's do the by name. So if I do array.sort by name, we can see that the array is now sorted in alphabetical order. I accomplished this comparison function by returning a -1 when the name of the first object is lesser than the second object, and I returned a +1 when the name is greater in value. And you can get creative with the comparison function, and you can define it in any way you want. For example, in this function called byPrice times IDUp, I am going to sort the array based on the price multiplied by the ID. So let's test that out. And there we have it. Now it is sorted in the way we defined it. And one last sort I want to show you is a pseudo-random sort using the math.random function. I am going to sort the array randomly using this function. So let's try this out. One thing about this pseudo-random sort is that it is not statistically random, so you should use it with caution. The next question is, what is the difference between let and var? The difference between the two lies in their scope. Var is scoped to the nearest function block, while let is scoped to the nearest enclosing block. Now, if the nearest enclosing block is also a function, then the two will act the same. However, if the nearest enclosing block is a for loop or an if statement or something else that is not a function block, a variable declared with let will have a more limited scope than a variable declared with var. Let me demonstrate this. In this first function, I have created a for loop, and I have declared the variable I using var. Next, we're going to see if I is accessible outside of this for loop. So let's run the function, my function var. And as we can see in the console, I is defined after the for loop, and it has a value of 5. Now, in this next example, I have also created a for loop, but I have declared I using let. And now let's see if I is still accessible. So if I run the function, my function let, we can see that I is undefined after the for loop. Therefore, if you are declaring a variable that probably will never be used outside of its enclosing block, it is better to declare it with let instead of var. The next question is, how do I change HTML elements in JavaScript? The first step is referencing the HTML element in JavaScript. The next step is adding an event listener that will fire an event handler when an event is triggered. Finally, the last step is modifying the HTML element attributes. Let me show you an example. In this example, I will be creating a horizontal bar that moves with the mouse. So first, I'm going to reference the block by using the document.getElementById function. I'm going to pass in the ID of this element. Next, I'm going to add in an event listener, and I'm going to listen for any mouse movement. Lastly, I'm going to add an event handler that sets the width of the block equal to the x position of the mouse. So end result, I move the mouse and the block grows and shrinks with the mouse width. The next question is, how do I check if an array contains an object with a certain attribute? In the code, I have created an array and added 100 objects to the array. Each of the objects has a randomly generated ID attribute. So let's say I want to know if the array contains an object with an ID of 25. I'll show you two solutions on how to achieve this. One is very simple, while the other is sort of more elegant. This first solution uses a simple for loop, and basically it checks every element to see if there is an object with the specified ID. And if no objects are found, then it will simply return false. So let's test it out. Contains a, let's pass in the array, and then let's look for 25. And this shows that the array does have an object with an ID of 25. Now let's look for an ID that's not there. We know that 1,000 is not going to be there since I've set the limit between 0 and 100. And as we expected, it returns false, which means that an object with an ID of 1,000 was not found. The next solution is pretty neat. It uses the filter function to narrow the array down to elements such as specified by the filter. And in this case, we're going to specify elements with the specified ID. And next, if we check if the length is at least 1, then we know that there is at least one element in the original array that contained the specified ID. So let's test this out like we tested the other function. Contains b, pass in the array, and let's look for 25. And there we have it. It is true, which means that the original array did have an object with an ID of 25. And if we check 1,000, we find that it also is not there, just like the other one. Thanks for watching. This has been Top 10 JavaScript